So next topic is related to the fits. Next topic is related to the fits. It is the relationship that exists between. It is the relationship exists between two mating parts. That is whole and shaft. A whole and shaft with respect to their dimensions. Dimensional difference between assembly. With respect to their dimensional difference between assembly. There are three types of fits are given under, right? So according to the relationship between the existing two mating parts, that is existing relationship between whole and shaft, right? Existing relationship between whole and shaft with respect to their dimensional difference before assembly, dimensional difference before assembly, right? So now you observe here, this is the whole. Left side on the right side on the screen consists of a diagram which representing hole and shaft. In between the hole and shaft there is lot of gap is there. So if gap is more, then we can say that it is a clearance fit. That means loose fit. So it is so observe here the definition related to the clearance fit. It is a fit which always provides clearance. Okay, always gap will be there in between the hole and shaft, right? So that's the gap we call it as clearance. Here the tolerance zone of hole will be, the tolerance zone of hole will be above the tolerance zone of the shaft. Tolerance zone of the hole will be above the tolerance zone of the shaft. Maximum clearance is the difference between maximum hole and minimum shaft. Maximum hole and minimum shaft. Minimum clearance is the difference between the minimum hole and maximum shaft. Minimum hole and maximum shaft is the minimum clearance. Maximum hole and minimum shaft is the maximum clearance. Okay, this is related to the clearance fit. Coming to the next fit, it is the transition fit. Okay, transition fit. You can observe the left side of the diagram consists of hole, right side it consists of the shaft. Right. You can observe the tolerance zone. Okay, size of the hole is less, but size of the shaft is high. If this is the condition, shaft will not fit into the hole, then we can call it as interference fit. We can call it as interference fit. It is a fit which always provides. It is a fit which always provides interference. It is a fit which always provides interference. That means there is no any gap. Okay, hole size is small, but shaft size is big, which cannot insert it into the hole. So proper fitting will not happen. There is no any gap. So that type of fit we can call it as interference fit. Here the tolerance zone of the hole will be below the tolerance zone of the shaft. Tolerance zone of the hole will be below the tolerance zone of the shaft. Right, zone of the shaft. Maximum interference is the algebraic difference between the maximum interference is the algebraic difference between the minimum hole and maximum shaft. Minimum hole and maximum shaft. Maximum interference. Come for minimum interference is the algebraical difference between maximum hole and minimum shaft for minimum interference. Right. Coming to the next fit. So coming to the next fit, it is related to the transition fit. You can observe the hole here. You can observe the diagram related to the transition fit. Three diagrams are there. Hole and shaft, hole and shaft, hole and shaft. Three diagrams are there. If you consider the first one, if you consider the first one, clearance fit, there is a clearance between hole and shaft. Interference fit, there is no any gap. Transition fit, only half portion of the shaft can fit into the hole, right? Or exactly hole fits into the exactly shaft fit into the hole or upper limit. Okay, shaft will meet the hole at upper limit. So like that, three transition fits are there. So in definition of the transition fit is, it is a fit which may sometimes provide clearance and sometimes interference, right? So fit which provides sometimes clearance, sometimes interference. Okay, that type of fit is known as transition fit. Okay, sometimes clearance and sometimes interference. Sometimes hole will fit in the shaft, sometimes hole will not fit in the shaft. That means hole size is big compared to the hole size is small compared to shaft size, or hole size is big compared to shaft size. Then we will get clearance and interference. When this class of fit is represented graphically, the tolerance zone of the hole and shaft will be overlapped with each other. The tolerance zone of the hole and shaft are overlapped with each other. So this type of fit we can call it as transition fit. So when we will prefer this type of fits, that is clearance fit, transition fit or interference fit, when we are going to prefer is in case of mass production. Okay, so what is meant by mass production? Mass production means production of a unit component or part in large number, right? For example, nuts and bolts will produced in large number, right? That is the mass production, right? That is the mass production.